So welcome everybody to the first session for Boulder Startup Week. This is the Internet of Things track, and I'm Chris Meyer. I've been hosting the IoT track for, I believe this is the 7th year. So it's been really fascinating to see not only the way the industry has changed, but also from personal experience, what it takes to build hardware and build companies around hardware. And on that front, what we've got today is Steve Bain and Joe Patton from Festo to talk about some of the things that they've seen on a global scale when it comes to creation of manufacturing and automation and all of these other systems that involve the intersection between hardware, software, and the actual bringing products to life. So the context behind this has been there are so many different ways that entrepreneurs, especially when they get started with a hardware business or connected device business or anything like that, they end up reinventing the wheel time and time again. And so Steve and I had an initial conversation about what they've seen, and Festo being a multinational company. How many countries is Festo in?
160 something. It's global.
Yeah. So you've seen some things.
Yeah.
So Steve and Joe are going to kind of share some of the things that they've seen as ways to try to avoid reinventing the wheel when it comes to manufacturing hardware, connected devices, and all these different things that we all will eventually deal with bringing a product to life. So Steve, that was my introduction for you guys. Joe, take it away.
Sure. So my name is Steve Bain. I'm the industry segment manager for food and beverage for Festo. I know a lot of startups aren't necessarily focused on food, and I also know a lot of startups would never be anywhere close to using our components just because we don't supply that type of thing. But for a lot of the things where we see automation going, where I see automation going, dealing with fast food automation or agricultural automation, these types of things where you're looking at physical manipulation of food or fruits or being able to sort different things. All these different things require physical movements that can use our components. So our perspective on this is supplying these components to these companies, but I think it can apply to a lot of other types of products that wouldn't necessarily use specifically what we even offer. Joe, do you want to introduce yourself?
Yeah, I'd love to. Just a little bit. So I'm Joe Patton. I'm a Festo sales engineer. I cover Colorado, based in Boulder, but I also cover all the way out to the Northwest. I do a lot of the hand-to-hand interaction with startups and even larger companies as well. Anything from cannabis industry to the medical industry, and kind of see these problems day to day where engineers work their way into their own kind of pickle. And yeah, that's just a little background on me.
Awesome. So Steve, where do you want to get started? Like, what is the thing that you've seen like most common with startups where they either go chip down at the wrong time, they start from just an academic perspective instead of a reliable perspective? Like, what seems to be the most common pitfall that you've seen so far?
I think one of the biggest things that I've seen is where companies realize that their machine needs to be low cost to be able to make it to market. And they focus on actually low costing it immediately without even thinking about ways that they could identify ways in the future to low cost if they need to. But for now, let's just use a commercial off-the-shelf component that will work, be able to prove our machine, be able to prove the market. And then at that point, once you've kind of developed and you've settled on this is what it's going to be, then you start low costing. You should design with low costing in mind, but if it's not the core of your value, if it's not the reason that your startup is even existing, there's no reason to just make a new one.
Got it. Is there any examples of where you've seen kind of that mentality play out?
One of my favorite ones is from the movie Big Hero 6. I don't know if you've ever seen the movie. It's a great movie for engineers and nerds alike, but there's a scene in there where the main character sees the robot for the first time, and let's just roll the clip.
Okay.
Titanium skeleton, carbon fiber. Right. Even lighter. Killer actuators. Where did you get those?
I machined them right here in-house.
Really?
Yep. He can lift 1,000 pounds.
Shut up. You have been a good boy. Have a...
So you've got titanium actuators that have been built in-house.
Yeah.
Exactly.
And just a quick Google search, pulled up a couple different options of standard actuators, like if you needed it to be stainless and pretty or whatever, like those things exist. And then even looking at the technical specs, I mean, it's a hydraulic system. There's even a 3/4 actuator, hydraulic actuator can lift over 1,000 pounds at 3,000 PSI. There's 3 of them. So like the technical specs aren't that far off. And yet here's a guy building a robot from scratch, spending all this time and all this AI and all these customizations. And yet he's going to sit down here and figure out how to make a hydraulic cylinder. And maybe he thinks it's fun. Maybe he thinks it's, worth bragging about, but ultimately it's not worth his time. And that's the thing where I think we see more and more within startups of, why are you even doing that? Because your investors are paying you for the end product, not for you to try to low cost something and do an expertise on something that you don't really have as your core expertise.
Got it. Yeah, and I've seen this over and over again, where it's $300. I could build that for 30, but you end up spending 10 months to build it.
Yeah.
And you're not the first one to do it, not at all, right? I mean, and I just to kind of coattail off that, it's when people forget where their value lies, they kind of get sidetracked with the kind of whole startup, philosophy or mindset of doing something, being innovative and doing new things, but it's kind of, pulling their hive mind off track a little bit, when you could manufacture a machine and product really well, but that's not really the point, and so it's kind of recognizing that might not be your value, or that it already exists out there.
So. There's another challenge with this too, in that, because the maker of the robot didn't approach a supplier of hydraulic actuators, they're missing out on the entire knowledge base that can possibly come with that, in terms of maybe better ways to mount it, or maybe where to place certain valving or other technologies that might be a good fit. They're just looking at what they know, redoing it, and they think they're saving cost, cutting out the middleman, when in reality they're also cutting off a really good information and expertise stream.
Interesting. So what's the thresholds? Like, have you guys seen anything where that might have played out in the entrepreneur's advantage, or have you never seen that in your experience?
It's a good question.
Joe, have you seen any situation where it's like, oh dang, you actually did save money and time?
Yeah. I've seen, I've seen some fancy things done with microcontrollers, that where they have gotten it to work, and they've really, like, they have a guy who's just lights out good at programming, and he'll build something from scratch and really have saved money, but the amount of time that happens is so rare. I mean, so it does happen, but and I've seen it done, for the programming one in the semiconductor industry, where he programmed something. He was moving $1,000 silicon wafers with an Arduino board, and he had multiple running on his machine, and no one would have told him to do that. But you can do that and invent your own way, but you probably shouldn't. You know what I mean? So there are success stories, but it's you take a gamble, and with as many of we've seen, that's 1 in 100 kind of chances.
Okay, so unless that you are extremely gifted in some area of relevance,
or lucky.
Yeah, or lucky. Okay.
Yeah.
Awesome. Steve, sorry, I didn't mean to cut you off there. Were you going to add anything to that?
Yeah, and so like one of the big things where we see a lot of potential and where we think the market is going is with adaptable gripping and being able to pick up things that you could never pick up in the past.
Mhm.
And the problem we're having in the market is the market's moving faster than anyone can develop these things for. And so companies that are developing their own proprietary gripping technology for specific applications, the companies that do it right tend to hit it pretty well. But that's largely because it doesn't exist. So companies that are reinventing things that already exist is really where I think there's a disadvantage. And so, you and your startup are with what you're making, can you find it commercially? And if the answer is yes, you should probably do that.
So, and the caveat being, as long as it's not the core of your business.
Correct.
Okay.
Right.
Yeah. And I mean, the other part too is like, what does commercially mean? So problem one, people look at whatever component it is and they think, they go to the Fry's website or Micro Center or a local, Granger or something like that to pick something out. They see the price and be like, I can make that for 1/10 of the price. So,
yep.
Well, in reality, if you can find the manufacturer of that component, you can probably get it for that.
Mm.
It's a matter of chasing down that supply chain and being able to have a broader conversation about high volumes of things so you can help reduce that cost.
Interesting. And have you seen other companies do that successfully, where did they decompile the commercial offering from like what the components that they needed?
We had one company they're working with tell us that they love our stuff, but there's no way they're going to go with it long term because we're way too expensive. I was like, well, this is the first time we talked. So let's start talking about, what kind of your volume productions look like and things. And the quantities they were talking about would actually shift our global supply chain in terms of what we needed to produce of a given component. And at that point, like you're talking about going to our sub-suppliers and talk about extra volume buys and things. So yeah, you can make things happen that might not seem possible within this community.
Got it. So having those discussions, even if it is overpriced, is in your advantage regardless.
Oh, absolutely. And even if your end goal is to make it yourself, you kind of now know where the floor is on real world. Like, it takes a lot to get operations up to speed on some of these things. Are you a manufacturing company or are you a technology company?
Got it. So I want to take a step back because I think we touched on something that's like kind of the foundation of what it is primarily where you've seen the misallocation of resources. Like how have you seen startups do that and the other areas where that's just not the right approach?
Another interesting one is there's been a couple of companies where they've written their own industrial protocol.
Okay.
And
so give me give me an example of an industrial protocol that somebody might encounter.
So there's like Modbus, Ethernet IP, Profinet. So these are ways that industrial machines all talk to each other.
Okay.
It's not quite as standardized commercially. I mean, there's Ethernet communication, but there's all these different languages and things. But at the end, to sit down and rewrite just make up your own language for how to get all this stuff to talk seems like a colossal waste of energy and effort when you could, at a minimum, currently use an existing technology and then just have a couple like localized interfaces if you need something special. But even if it's a long-term vision, it's still not your core competency. You're not selling industrial protocol. You're selling what they're used for.
Mm-hmm. Okay, so the reinvention of protocols, where have you seen that happen? So I'm just trying to ground some of these things where people start to connect with their own, like, oh, I probably shouldn't do that. Or Joe, some question for you, like, if there's anything that comes to mind, example-wise.
For protocol specifically, or?
That's what we're talking about right now. But if there's, yeah.
Yeah, I mean, so protocols one, especially in the kind of startup community, would be one where if you want to communicate at speed, or something like that. So industrial protocols are what they call real-time communication. So these guys had the idea that we want something that communicates right away, and it's faster than standard PC communications and that kind of thing. And so they go down this path of creating something that then kind of pigeonhole them so they can't use hardware down the line because the hardware on their device. So yeah, their main processor uses their language, but now they don't have any devices, field devices, that communicate in that same language. And so then they say, okay, well, the field device communicates in this language, and now they're trying to translate between an existing protocol and their little PLC, or their little microcontroller, and it really now they're getting out of their element again, and so it's really where I see it important is for them to orient themselves and do the research and figure out what's there. In communication is really one of the biggest ones I see. So it's not just protocols; it would be communications from standard sensors or field sensors, and figuring out power requirements, and then like so out and in, so what voltages are common, what analog or digital, and knowing what's out there and then designing kind of with those ideas in mind. You don't have to kind of choose one or the other, but it's people not understanding the decisions they're making, especially in communication early on, that really kind of slow them down a lot.
Got it.
Because every time you make a decision like that, you reduce your potential future supplier pool, your potential future knowledge base, your potential scalability even. What if you pigeonhole yourself down into something where there's not that many suppliers that can ramp up to a global level? That becomes a challenge in itself.
Got it. And I want to bring this back from an IoT, a connected devices, robotics, and any sort of electromechanical endeavor. Like this is especially important for everybody to understand, is that if you're going to be super innovative, you need to make sure that innovation is in an area where you are competent and can add value. Like if innovating on protocols to innovate on protocols, like isn't going to end up with a good outcome.
I agree with that. And I think another somewhat common problem is you get a lot of startups that come straight from academia, from school, to the startup, and they've learned in school how to build these things. So they are competent in these things. What they're lacking is the knowledge that there's somebody maybe down the road that can sell me this, be a better expert, and let me do other things to keep my company moving forward.
Yeah. So how does, just out of curiosity, how does Festo handle, because you guys are dealing with a lot of very complicated, not only in the protocol level, but also the control or the real-time, operational requirements of manufacturing. But how do you kind of integrate some of the folks that are coming from academia in with kind of that real world experience?
I think a lot of people, once they see what's available out there in the market, really just kind of take a step back, and their mind's a little bit blown on how big the existing supply chain market is for these types of different things. It's more than the little tool crib that you're used to in your college that you were digging into. It's more than the random parts catalog that was sitting on that shop floor. There's a lot of different things. There's a lot of different resources, and it might seem overwhelming, but it's not. It's really just about reaching out to these companies and saying, "Can you help me?" And if enough companies tell you no, that's probably a good time to start looking at, can you do it yourself?
Okay.
Yeah, and just to kind of continue off that, so usually what I do, especially with guys that are just coming out of school, is like when talking about their problem, what they want to solve, just break down the language, really understand, what the words mean in an industrial application compared to what you're used to, in a school or academia, when you really understand both of them, but it's just a different words that people are using. And so they understand, really the mechanics of what's going on, but it's just that industry uses slightly different words and terms. I mean, we've all gotten on Google and looked for something for days, and then all of a sudden you get one right search term and it gives you everything you want to know. And so really breaking down the language and making and not letting it scare you is really kind of the first step of going from academia to the industrial world, because it's not that different. Physics is still physics. So that's about it.
So having that foundational knowledge, even though initially it might seem irrelevant, is actually super relevant. You just need to know how to talk about it.
Exactly. Yep.
Awesome. So Steve, I had a question for you.
Go ahead.
And Joe, you as well. So let's say that you're fresh entrepreneurs, and you wanna build the next minute key or something like that. Like
Sure.
what would you? And for context, Minute Key is a Boulder company that started to do on-demand key duplication, right?
Yeah.
And so they started with the CNC in the mill, and then they have a phone app, I believe, that allows you to like request duplication services. I haven't looked recently, but there's all these different components. So you're a fresh entrepreneur, you have this idea that involves some level of communication, business, and in this case, manufacturing and hardware. Like
Sure.
what would you do first?
The first thing I probably do is really lay out what it is that I'm doing that's special and what it is that I'm really good at.
Yeah.
And if you can identify what's proprietary, and if you can identify where your skill set lies, that starts to define what everything else is. And a really good first step might be to chase down a local engineering house that supports startups. There's a lot of consultation companies. Some are more geared towards small startups, some are more geared towards big startups. And so finding those where you can have a conversation, I think those steps are important. Another big step is kind of looking for free advice where you can get it. So talking like a company with Festo, if you wanted to come over and say, hey, how would we think about, moving a key around in a machine, that's what we do. And like just that conversation doesn't cost us anything, doesn't cost you anything, but you're going to get a lot of knowledge. And we're going to continue to try to support that process as it goes. From there, talking about prototyping machines too, we can do that. We can build an initial kind of concept, that kind of design, and you probably can too. But if you let us do that while you're doing other stuff, we just expedited your time to market pretty well. So you got to balance cost and time for sure, but you should be leveraging expertise where you can.
Got it. Joe, any thoughts on that?
Not a ton to add. I mean, he kind of nailed it. Exactly what I was going to say is just understanding where your value is and where your skill set is, and then what you're trying to do differently. And just really, understanding that, and then going back to what we were talking about on then figure out what's out there already that might go into your system and have a loose understanding of that. And then to kind of add on one more point of Steve's, when you reach out to, somebody, in industry or, you venture out a little bit, even having a conversation where you don't really know what you're looking for can be extremely helpful, because we've all had the kind of conversation where a guy, where you loosely know what you want, and then all of a sudden he starts using these terms and you're like, oh yeah, okay. And then you Google them afterward. It can really save you a lot of time. And so I think a lot of guys find that they think they might be the only one running into these problems, and a lot of time they aren't. And so really kind of getting out of your comfort zone and just poking around and seeing what's out there is really important in the beginning stages, because it kind of can set the context for how you should move forward.
And I think a good example of that, and kind of tying everything together, even with pigeonholing, is we had a company reach out to us about a new automation machine, and we started talking about what they were trying to do, and I'm like, all right, so what kind of PLC are you guys using for your controls? Like, oh, we're not using that. We're going to use a PCB board. And it's like, you don't even know how you're going to do what you're trying to do, yet you've already pigeonholed all the ways you could possibly do it because you've low costed this one component. And so the PCB board isn't their tech. It's being able to do the awesome automation that they're trying to do. And if you can do that at the end of a day with a PCB board, do it, absolutely. But that shouldn't be like not spending $100 or whatever it is on a PLC or an Arduino or something that's programmable shouldn't be your limiting factor on technology.
Got it. And for those that might not be as familiar, the differences between a PLC and you're building your own PCB in a manufacturing context. Can you just kind of outline some of it, like to bring it down?
Right. So once you go to PCB, you're stuck with it. Okay. It is what it is. And even an Arduino is programmable, but there's limited I/O, there's limited functionality. Industrial PLC is, they're really commonly used, but they're freely programmable and also expandable. So you can have additional I/O points, additional network points, different things controlling servo motors and anything. They're built for long-term, tough environments, that kind of thing. That's a great starting space because there really aren't very many limits on what you can do. And if you can build your machine around that while thinking through every step of the process, is this something that I could make into a PCB board long-term? And then coming to a junction maybe where this certain technology can't really be done with a PCB board for whatever reason. Now you kind of got a choice, but start with a PLC, carry that forward, try to design your programming and your logic with PCB boards in mind. But then at that point, kind of once you got it lined out, then maybe go build that PCB board.
Got it. So for just another layer of context here, and this is all in the realm of kind of automation and some sort of like larger scale system control.
It doesn't have to be large. It could be a small machine like a minute key kiosk or whatever it is. It's I've never peeked inside a minute key machine. I'm sure they don't have a PLC though, because there's what they're doing is standardized. It's off the shelf. Every single thing's the same. But like if I was going to build a new drink dispenser for a fast food restaurant, yeah, long term that needs to be super low cost. It's never going to change. But Rev 1, that's going to have a PLC because I don't know what Rev 2 is going to need to be. And I don't even know if it's going to be successful in the market. So why would I spend time really ironing all that out ahead of time if I don't need to?
Got it. So the abstraction here is make sure that you don't over optimize up front.
That's a great way to put that.
Awesome. So
yeah.
for I don't know if you guys were, I went through Y Combinator back in the day. And this is one of the things that I was beaten over the head over and over again. It's like, do things that don't scale. Don't over optimize too early. Like it is such a common problem, and especially those of us that have like kind of an engineering mindset. It's like, I can solve any problem if you give me enough time and money. Unfortunately, those are the two limiting factors for a lot of startups.
Well, for everything, right?
Well, yeah. Maybe not every one, but you know how it is. But yeah, so don't over optimize, don't solve problems you don't have to, unless it is core to the value proposition that you're trying to offer.
Sure. I think another thing too is companies, once you pigeonhole yourself into building your own product, now you got to find a way into manufacturing it. And now you have to become a manufacturing company along with also becoming a technology company as long as you be a startup. And that poses a lot of challenges. There's way more to it. Something always goes wrong, and it's more expensive than I think people realize to do that.
Yep. So again, my experience starting, being on the founding team of Mr. Robotics, it costs a lot of money to go to manufacturing. and it takes a lot more time than than a lot of the scenarios that you think are likely are actually going to take. So I'm curious on that front, if you guys have seen any best practices from companies that might, let's say they have a Rev 1 that works, let's say they're trying to scale up, like what types of practices that you've seen that are best practices to take that step going from like the first 100 to the first 1,000, or the first 1,000 to the first 10,000?
So if Rev 1 has been built with common things in mind, whether it's like, as an example, like if your machine were to use pneumatics, use ISO cylinders, because then it doesn't matter what brand you chose to begin with, because it'll be a drop-in for whatever brand you end up long-term. And so you're not going to waste a lot of time on that first Rev in finding the right supplier necessarily if it's not the core component of what you're doing. But then Rev 2 is when you can go now start to branch out into the other markets, start talking to different suppliers, start talking about large quantity type things with direct to manufacturing, and start to really be able to better understand what your long-term costs are going to be.
Yeah, and just to kind of throw my answer in there, it would be having tolerances or ranges that are acceptable in certain devices or any choice you make. Document kind of why you made that choice when you did, and keep that around for whenever it comes up again if you have to. And because when you really go through in the beginning stages of, okay, what do we need here for this little widget or whatnot, you'll sit down with your team or by yourself and kind of write down what's important to you. Keep that around for when you need to revisit it, because then you can kind of have your thinking. Because I've seen guys change things where they then realize, oh, we did this for a certain reason, but there was no documentation to it until they were troubleshooting on their Rev 4 version and realized I just had one tiny piece missing. But so I would just say write down the reasoning for the decisions you're making and keep those around for each iteration. And it's important to include other people's contributions as well, just in one place for whatever kind of widget or component you think is a choice or a decision.
Got it. So any spec that you come up with as to why it operates the way that it does.
Yeah. Anything you make or anything you go through a make or buy decision on, if you're either going to make it or buy it, just write down a quick kind of background of your thinking at the time, because it's just useful to have. But yeah, it's pretty much it.
Like a real example would be, let's say you've done your PCB board, you're ready to go to market, and you've got something that requires an analog output to work. And the device that you selected at the time is 0 to 5 volt range. So you put that in your PCB board. Well, if you instead have made that 0 to 10 volt, you don't really lose any accuracy on the PCB side, but you've now really opened up the future potential market for alternate components if you needed to have that.
Got it. So, for connected devices or any of this other stuff, the voltage operation and what sensors and peripherals or anything else are available should be part of your initial, design discussions.
Exactly.
Yeah, and for the documentation portion of it, for the first, for Rev 1, it's going to be kind of hard to do because you're kind of, not, winging it or walking it slowly. But even at the end of that, when you find out what works, once you figure out it works, just write it down then. You don't need to document the whole process, but once you're moving on to the next segment, just write it down. That's about it.
And so in some of your contracts or some of the works that you guys are doing with clients and customers, how many of those people have done that? Just out of curiosity.
I mean, in the startup world, I'd say about half.
Okay.
Some guys are really good at it. But it's because it's not their first startup, right? So they've gone through and had those mistakes, and those are the guys that write it down. But as you guys, or as in the startup industry, you don't get your first one right most of the time, and so usually it's the guys in the first go around that have to learn that the hard way.
Yeah. Steve, has that been your experience as well?
Yeah, I actually haven't seen a lot of what I'm looking at is extremely new markets, and there's companies getting into this that have never been into it before. So I think a lot of what I'm dealing with is those first timers at the moment. But that's
Yeah, you have to have the pain to make the lesson stick sometimes, huh?
right, exactly. Yeah.
Well, awesome. So I have one little note, just from like a venture capital and an investment perspective. How have you guys encountered the way that your stakeholders and your investors look at resource allocations versus the practitioners, the people building it, look at it?
I don't think companies look at this as significant of a problem as it is for they're listening to their engineers. Yeah, I need to go do this. I need to go do this, and they're not really sitting back and thinking, did that person try to find a way that he wouldn't have to do that, or did she really need to take that on herself, or could she have used another resource to accomplish that at a fast, because ultimately it's speed. I mean, that's the thing that we keep talking about: speed to market, time to market, all that kind of stuff. And if you don't get your prototype out there, tested, test the market, ready to go, it doesn't matter if you've low costed it if you're a year late.
Yeah.
Yeah, and just to add to that, then from the investor side, I've seen it's the large scale project timeline. It's kind of what Steve said. It's how fast you did it. But they never go in there and they never look at what you've done and say, oh, you use this off the shelf and you didn't invent your own. It's so where you can save time is really kind of where it's important. If that's where your value is, that's why we said first understand where your value is. But you can really save time by making the right decisions on, or making it or buying it, or understanding kind of how you pigeonhole yourself. Because in the end, time is money, and burn rate, it keeps going. So.
Have you guys had any experience with like bootstrap companies? I know that what in hardware
All
it's
the time.
really difficult.
All the
Okay,
time.
awesome.
Yes. Yeah.
So just anecdotally, it's very expensive for a lot of the equipment that it actually takes to build that first prototype, that first iteration. And I'm curious, like on the other side of the coin, for people that don't have capital at their disposal to trade time for money, if you don't have the second part of that, how have you seen kind of the bootstraps organizations, companies kind of mitigate some of the things that we're talking about?
Yeah, I mean, I think the smart ones I've seen, or in my opinion, smart is they, an investor always says, "What are you going to do with my money?" Well, when you've made those bootstrap decisions, you've kind of, you show that you've understood the decisions you made and how they're, you purchase parts off Spark Fund, and then it doesn't really apply to scale, but you say, "Hey, this is where my money might go," but it's making, the decisions to duct tape your first one together, and then saying, hey, recognizing that that's a weakness, and then that's where the kind of money will go, because it doesn't need to be perfect the first time, but you do need to understand that it's not perfect.
I think it's also smart to try to look for partners where it might not cost you anything. If there's a company that's doing a certain thing and automating of a fast food restaurant or something, and they were really struggling but they're struggling for money, but they had a good vision. They know where they're going with it, and they came to me like, there's a good chance, depending on skill, that we'll just supply components for testing or for improving the principle or that kind of thing. Doesn't always cost money, because if you can find people that would benefit if you benefit, those are pretty good partners to have.
Gotcha. So let me try to rephrase it. So if I'm a starving entrepreneur that doesn't have or doesn't want funding, then understanding the suppliers and what the success looks like for them, that you could potentially get the components and the support you need by adding value in terms of a story or an implementation possibility. Is that
kind of talking about long-term partnerships too? It's like hey, we want to use your stuff, to test, to play with this. And if it takes off, we really want to be your partner long-term. That's a compelling story for any company.
Awesome. So being resourceful in how you structure your value proposition here.
Exactly.
Becomes part of the strategy around like buy versus build. If you can get experience with the components that you might want to utilize without having to spend the money on them yourself, then that's a win for your company long term anyways.
I mean, some companies have venture capital, we have venture components,
Is that a thing? I've never heard that before. Venture components. I love that.
I don't know.
See, we patented right now. You can't just take that.
It's a thing now. Exactly.
It's a thing now. That's fantastic. Yeah, because I mean, in essence, that's what a lot of especially in IoT and radios. Hey, just go use this. Here's a development board, and they a lot of them will hand them out like Pez. So just trying to build up that the base of users, but venture components is a good word for it. I like that. Well, cool. I think that kind of covers the foundation of it. Anything that you guys want to close with? Anything that we didn't get a chance to cover?
Well, we talked about ways to look for how companies should be viewing this. What are some longer term things that we could and should be doing as a startup to better prevent these types of things from happening. And I mean, part one is being conscious of these types of decisions. Mm-hmm. Just because you know how to do something doesn't mean you should do it, right? And even if you can do it in a few days, if you can pick it up at a Home Depot, you still shouldn't do it. And I believe that as a rule. But I think another big thing might actually be in the university level, and I don't know the best way to necessarily approach this, but would be to get universities to get someone to learn how to program their own robot or to make their own motor. But at the same time, when you're looking at a project like that, look at what's available commercially so that you better understand how the thing that you just did could also just be bought. And that'll help you better understand where the value lies.
Yeah, I know that some universities are starting to think in those terms where, the difficulty of transitioning from building it myself and understanding all of the theory behind certain components in electromechanical design to, I can actually meaningfully use these components in an industrial setting is a different skill set sometimes.
Right. So I'm a chemical engineer by degree, right? So I left school learning or knowing how to spec a distillation column for the oil industry. So I left knowing how to do that. Uh-huh. I have no idea how to do it anymore. But then getting into the real world, you realize that there's lots of companies that just sell this. So you don't need to know how it necessarily works completely inside and out. You can just ask them and they'll help you. Got it.
Yeah. And so this is an interesting thing. So Steve, what's your educational background?
I'm a chemical engineer from Wisconsin.
Got it. Okay.
And then went to work for Ecolab, which is one of the world's largest soap companies out of school. And I was a project engineer running capital projects. So I've been kind of on the maintenance and industrial end user side of things, and then moving to Festo now, those people are my customers, right? Selling to the people that are going to need this automation, that need that high-speed packaging equipment to make this other thing work better. And so I've seen both sides of those things, but I really don't know much about chemical engineering anymore.
And so Joe, what's your background? So I'm asking these questions just because a lot of the times during Startup Week, and we have conversations with people that are interested in these industries, but they don't how the hell did you land here? And it's just kind of interesting as to where we came from.
Well, so for me, how I landed here was they were looking for someone that had no sales experience, uh-huh. that they could train up to to better go to market in terms of really understanding how a customer would think, and especially a customer in the food industry. So where Ecolab made soap for the food industry, now I'm selling components that need to last longer in the food industry due to that soap. And so that was a pretty good fit from that perspective. And I've been here 9 years and loving it.
Awesome. All right, Joe, your turn. That's super cool.
Yeah, so I actually started with Festo right out of school. Kind of landed here somewhat blindly, but my background is industrial engineering, and then I have an electrical engineering minor as well from Iowa State. But yeah, went to school there, ended up interning with Festo, and just kind of seeing it early on. And so I went from, dead academia to, automation, and went through kind of what some of these startup guys are doing, or some of the academics are doing, where you're dead from school into the middle of the industry, and so you can really figure it out. And that's with enough time and asking around, is really kind of how I ended up here. So that's just a little background, I guess.
Yeah. The critical component is asking a lot of questions, I suppose.
Yeah, exactly. And there are a ton of people that like to help, in this startup industry, in basically any engineering field. You find out that the guy on the other end of the phone is also a nerd, and has some passion about, something. And so that's, the overall background is just ask a lot of questions and be passionate about it, and you're going to do fine.
Yeah. And that's, and in closing kind of this session, like what I want to emphasize, and because this is a part of Boulder Startup Week and the community here in Boulder, Steve and Joe, you're both in Boulder. So for anybody watching this week, like be sure to flag them down when we can. I hope you guys are wearing masks in public, but we can talk about that later.
I wash my hands too.
I wash my hands for the video session.
Yeah.
But yeah, it's just to anybody out there that wants to get into this, wants to understand, like the community is such a wonderful resource. You can ask me, you can ask Steve, you can ask Joe, you can like reach out and ask if we know of anybody that might be able to help with your problem. This is what we, at least for me, I'm so passionate about. The industry is fascinating. I'm constantly learning. And for my background is math and computer science. My first job out of college was writing tax software for the Department of Revenue. So my career has hit kind of a very strange arc. So for anybody that's looking to get into this, or in the middle of it, maybe feel a little overwhelmed, there's always help out there. But all right. The last thing I want you guys to do is try to, what's the too long didn't read of how not to reinvent the wheel with hardware?
I'm trying to remember what you said because it was really good. About not over optimizing.
Do things that don't scale.
Yeah, don't over optimize things that don't scale.
Yeah,
and leverage the commercial marketplace to the best of your abilities. There's knowledge, there's cost savings, there's scalability, there's globalization, there's all the things that come from that. And the less you take advantage of that, the harder it's going to be for you to get to where you need to be.
Which is wildly successful, we hope.
Yeah, and mine would be is get creative in solving your solution. Figuring out something yourself is one way to solve a solution. Learning from somebody else is another. Getting their help is another. Doing it by accident is another. I mean, you just have to get creative in how you solve a solution, and you can't get really two-dimensional and think that you have to do it on your own, because there is other things out there, and there are other ways for you to get to that next step and get over whatever problem you're trying to solve.
Excellent. Well, Steve, Joe, thanks for taking the time to kind of talk about this, and just being wonderful members of the community. So looking forward to more of these in the future.
Sounds good.
Absolutely.
Thanks.
We had fun.
Yeah. So that's the end of it.
So one of the people on our team works with a lot of the startups in Central Valley, California, where they're doing a lot of agricultural automation and trying to find ways to do that. And so I asked him for insight on this topic and, just what would he, if he had any ideas or things. And he didn't jump to any of the typical things of the companies he's working with. The thing he brought up was back when he was in college, he was taking an architecture class, and he's sitting there drafting up a house and trying to design it. And he asked the instructor how big he should make the doors. And the instructor's like, well, probably the normal size, so they're not too expensive. And that for him was kind of a light bulb moment, like, duh, like that's how big they should be. But it's also because they're available, and there's a lot of different options. You can make a custom door. It's just going to cost you more.
That's fantastic. I love that.
And then there's like another one that was in here was that different industries had different expectations. So knowing where you're pulling somebody out of really impacts their level of expertise, but also level of understanding in the world. If you pull somebody out of the aerospace industry, their expectations about metals, machining, tolerances, it's all excellent. But if I pull a plumber, they're going to know a lot of these things about welding and how to get stuff done as well. And you're going to end up with two wildly different results. Which is better for what you're doing kind of depends on what your product is. Mm-hmm. But if you're machining something out of 316 that could be machined out of 303 or 304 or whatever, why?
Yeah. And
if you have a good reason, great. But if not, it's cost.
Yeah. You don't need aerospace grade plumbing.
Right.
Exactly. unless it's plumbing on like a space shuttle, but that's a whole different.
Right.